All right, so 6.4, factoring polynomials. We spent some time at the beginning of the year looking at factoring, but I want to kind of go over it briefly again and then add in some things with some cubics. So factoring polynomials, we always want to look for the GCF first. Why? It always makes our numbers smaller. Smaller numbers are easier to deal with. So we're going to practice just that. So we're going to look at 6x cubed plus 15x squared plus 6x. They all have x's. And 6, 15, and 6 are all divisible by the number 3. So we're going to pull out the common factor of 3x. Now here's where your brain has to work backwards. You have to think, 3x times what value is going to give me that 6x cubed? Well, 3 times 2 gives me the 6. This says I have 1x. I need 3. It means I'm missing 2 of them. And then I go to a sign, and then all right, 3 times what is 15? That's 5. I have 1x, but I need 2, so that must mean I need another 1 here. Go to my sign and say, all right, 3 times what is 6? 3 times 2. This has an x, this only has 1x, that means I don't need any more x's there. The trick here is that I should be able to mentally go back and check my work. 3x times 2x squared, yep, that's 6x cubed. 3x times 5x, yep, that's 15x squared. 3x times 2, yep, that gives me 6x. But we're not done. We need to keep factoring. And just like what we've practiced before, we're going to bring down this 3x because it is a part of our answer. And we're going to work on breaking this piece down more. Well, since these signs are both positive, I know these are both positive. The only way to get to x squared is 2x and an x. Okay? There's no other way. You can only multiply 1 and 2 and get 2. Now, I need to come up with 5. And here's where that little guessing challenge game is. I'm going to put in 2 and 1 because that's the only way I can multiply and get 2. So this is my A value. This is my C. Okay, and we got to try to come up with 5. If I check this, that's 2x plus 2x. 2 plus 2 is not 5. So I'm going to switch these values around. And some of you are like, Ms. Sandoval, why are we going through this whole guess and check? It's just the way I do it. I know that there's other ways out there, and I know I've showed you other ways, but this is my favorite way. So we have x plus, or times 1 is x. 2x times 2 is 4x. When I add 1x and 4x, I get 5. So this is my answer. And if you leave that work, that check under there, that's okay. We're all good. Number 2. Again, common factor is always the first thing we look for. 2 and 20, they're both divisible by 2. X cubed x. So I'm going to take out a 2x. And I got to work backwards. 2 times 1 is 2. I like putting the 1 there because it helps me remember. I have 1x, I need 3, so that means I'm missing 2. 2x times what is 20? That means I need negative 10 because I have to have a negative. And then it already has the x, so I don't need to add any more. Now, I can't break this down anymore. So that's just my answer. I'm going to move my parenthesis over, and it couldn't break down. This one, it could break down further. The next one, not so much. So I have some rules up here, and I'm going to talk about some examples. These are some factor patterns. A squared minus b squared factors to a plus b, a minus b. It's called the difference of two squares. So, for example, let's do our example in blue, just for whatever's sake. 9x squared minus 16. Okay? So 9 is 3 times 3, so it's a square, and 16 is a square, and I have an x squared. So this would factor to, the square root of 9 is 3, so that would be 3x, and it says plus square root of 16 is 4 times 3x minus 4. And we can check this. 3x times 3x gives me my 9x squared. Let's see, 12x minus 12x means no middle, and 4 times negative 4, that's negative 16. So just kind of how it works. Perfect square trinomials. So if I am looking at something, let's see, let's go with 4x squared. Actually, let's start with a simpler one. We'll start with a simple x squared. And these are going to both be positive. And let's say this is 25. That would be 10x. So we're going to start with something real basic. The square root of this value, 5, if I multiply 5 times x and times 2, 5 times x times 2 is 10x squared. So this can be factored to x plus 5 squared. Okay, the same thing works if we had, let's make this, we won't go too complicated, and we'll just go minus 20x, and we'll put a plus 25. Okay, so same idea. This is a perfect square, this is a perfect square, so we end up with a 2x minus 5 squared. Now, you don't have to memorize patterns. You can factor this. You can say, the numbers that multiply 25. 1 times 25 and 5 times 5. Oh, 5 times 5 is 10. And we're good. Okay? And you can write it out as x plus 5 times x plus 5. You don't have to write this squared. I just want you to recognize and see it. The two new things we're going to be looking at are these cubics. These are two patterns. Perfect cube plus a perfect cube factors out to a plus b times a squared minus ab plus b squared. That's the sum of two cubes. The difference of two cubes, a cubed minus b cubed, notice is exactly the same thing except for where the negatives are. This one, the negative's here, and this one, the negative is there. So when we practice factoring these, we're going to figure out what a and b are. So we need to look at this and go, do we have a difference of two cubes? 27 is a perfect cube because 3 times 3 times 3. And 64 is a perfect cube because 4 times 4 times 4. So it's a sum, so that means I'm going to follow that first pattern. So I'm going to follow the pattern a plus b times a squared minus ab plus b squared. Now, I want to identify what a is. A is 3x. It's the cube root of that first term. And b is the cube root of 64, which is just 4. And I'm going to plug the numbers in. I've got this pattern I'm going to follow. It says, to follow it, that gives me 3x plus 4, 3x squared minus 3x times 4 plus 4 squared. So now we've got to simplify that second parenthesis. This first parenthesis, it stays 3x plus 4, 3x squared. 3x times 3x is 9x squared. 3x times 4 is 12x. And 4 squared is 16. And voila! We are factored. So let's look at a difference of the two cubes. Okay? So again, it's a difference. So I got to pay attention to where that negative is. A minus b. And I want to identify what a and b are. So I'm going to cube root both pieces. 8x cubed, that's 2x. That's my a value. My b value is 3. I'm not worried about the positive negatives because that's going to take care of itself with this little formula. So that's 2x minus 3. And then I have 2x squared plus 2x times 3 plus 3 squared. Now we're going to go back and we're going to simplify. Here, there's nothing to simplify. 2x minus 3. Here, 2x times 2x, that's 4x squared. 2x times 3 is 6x, and 3 squared is 9. And voila, we are done. I like that word, voila. All right, it's like magic. The equation, 3x cubed minus 27 equals 0, has 3 roots. How many of those are real? What are they, and how many are non-real? So notice, this equation was taken from this problem, and we need to figure out how many are real, how many are non-real, which means we end up with imaginary numbers as answers. So to determine this and figure this out, we actually need to go through and solve using the zero product property. Since I already know what it actually factors to, I'm going to simply take each of these factors and set them equal to 0. So 2x minus 3 equals 0, and 4x squared plus 6x plus 9 equals 0. Now, this thing does not factor pretty. So we do have to use that quadratic formula on it. This one, though, that's pretty easy. 2x equals 3, because we add the 3 to both sides. Divide by 2, so x is equal to 3 halves. Over here, I don't know what this factors to, so we're going to use that quadratic formula. In case you forgot, that is x equals the opposite of b plus or minus the square root b squared minus 4ac all over 2a. So we are going to kind of shift over and use part of our board here. So I'm going to create a little bit of space. A in this problem is 4, b is 6, and the c value is 9. And I'm simply going to plug it into the quadratic formula. So x equals opposite of b, that means negative 6, plus or minus the square root of 6 squared minus 4 times a times c divided by 2 times, a, which is 4. Now, from this point, I just have to simplify. So I'm going to start inside that radical. X equals negative 6 plus or minus the square root of 36. That is 16 times 9. 16 times 9 is 144, and it's a minus, all divided by 8. Now, I end up with a negative answer inside here, so x is equal to negative 6 plus or minus the square root of negative 108 over 8. Because there is a negative in the answer, or inside the radical, that means we have two non-real answers or solutions, because this is a positive one and the negative one, and we have one real answer. And that real answer is 3 halves. Now, we have one little thing to talk about, factoring by grouping. Factoring by grouping doesn't always work. Most of the time it does, but not always. So we're going to slide this over a little bit. I'm going to show you 2 ways, by using the box method and by not using the box method. So when you use the box method to factor, you kind of work backwards. So we're going to put the terms inside the box, because we're factoring, we're not multiplying, we're factoring. Since they're all positive, I don't need to put the plus signs. And I'm going to look and see what the rows and the columns have in common. So, going across this way, x cubed and x squared, they have an x squared in common. Going this way, x and 1, they just have 1 in common. It's the only thing they have in common. And then going down the columns, x cubed and x, they have an x in column. X squared and 1 is a 1. So this factors to x squared plus 1 times x plus 1. Now, I'm going to show you how to do the same problem, but not using the box. And I don't care which method you use. Use the one that works for you. A lot of people like the box method when they factor with 4 terms. So I'm going to look at just these 2, and then I'm going to look at these 2. So I'm going to just kind of basically factor it separate. And I'm going to look at the first 2 terms and what they have in common. They have an x squared. So I'm going to take out an x squared. That leaves me with an x plus 1, because x squared times x is x cubed. X squared times 1 is x squared. I still have that plus there. And these, they only have a 1 in common. You have to take out what's in common, and unfortunately, it's just a 1. Now, if you notice, I have an x plus 1 and an x plus 1. So I'm going to pull that out of both of them. They have it in common, so I'm going to write it out in front. And then what's left? X squared plus 1. Now, The two factors, they're in opposite orders, and that's totally okay. But you did get the same answer. So we need to factor this last one. I'm going to set it up in box method only because I think a lot of people understand the box method better. So we're going to make our box. The values go inside the box. 2x4, 2x cubed, x, and 1. It's very important that you don't jumble them all around. Just go in order. And we're going to go across. These have a 2x cubed in common. This row only has a 1. And going down, this has an x, and this column only has a 1. And there it's factored. 2x cubed plus 1 times x plus 1. Now, if this 2 were a perfect cube, then we could actually go further with that one, but since it's not, that ends everything we can do with this.